Let's talk about finding the x and y intercepts. First, let's tell me, what is an x-intercept? If we have a graph, you don't have to draw this, but if we have a graph, say I have a line. Actually, let's shift this a little bit. Can somebody tell me what is, just explain in your own words, what is an x and or y intercept? Olivia? Excellent. It's the point where the line crosses the x-axis or y-axis depending on what we're finding. So do we agree this would be right here the x-intercept and this would be right here the y-intercept? Now, whenever we have an x-intercept, we're moving along the x-axis. Are we moving up or down at all? No. So what is y? Y is always, I heard it, 0. Y is always 0. For the x-intercept, y is always 0. What about the y-intercept? So the y-intercept's moving along the y-axis. So it's up or down, but what is always x? We're not moving left or right at all. So the y-intercept, x is always 0. So whenever we're finding an x-intercept, we're going to let y equal 0. And whenever we're finding the y-intercept, we're going to let x equal 0. So in number 7, it says find the intercepts of negative 4y minus 12x equals 32. So let's start off by first finding the x-intercept. We are going to let y equal 0. So we're going to take our equation. We have negative 4y minus 12x equals 32. And wherever I see a y, what am I going to substitute in? A 0, exactly. So we're going to have negative 4 times 0 minus 12x equals 32. Well, 0 times anything is 0. So we're 0 minus 12x equals 32. So we are at a negative 12x equals 32. Divide by negative 12 on both sides. Does 12 go into 32 evenly? No, but can I simplify this? Yeah, we can. 32 over negative 12, we can divide top and bottom by what number? 4. And what are we going to get?
8 over 3.
Good, negative 8 over 3. I always assign the negative to the numerator. So even though it was in the denominator, I just reassign it to the numerator. It doesn't matter. If you wanted to keep it in the denominator, that's fine. So now the x-intercept is at negative 8/3. I would leave it like that. I wouldn't change it into a mixed number. If you wanted to, you could. I leave everything improper unless I have to, unless it's going to make it easier for me. So now we always represent the x-intercept and the y-intercept as a point because, right, it's the point where the graph crosses the x-axis. So our x-intercept's going to be the point negative 8/3, comma, what did we say y had to be? 0. So this is our x-intercept, and we always write it as a point. Now let's go ahead and find the y-intercept. So for the y-intercept, we let x equal 0. So we're going back to our main equation. We're at negative 4y minus 12x equals 32. This time I'm going to substitute in a 0 for x. So we're negative 4y minus 12 times 0 equals 32. 0 times anything is 0. So here we're just at negative 4y equals 32. Divide by negative 4, we get y is equal to negative 8. Do I leave it like this? No. How do I write the y-intercept? Mariana? You got it. We write it as a point, so this is going to be the point 0, negative 8. All right, so we are bringing a little bit of geometry into this in number 8. I'm bringing a definition. Are the points negative 6, 5, 1, 7, and 15, 10 collinear? We got to remember what that means back from chapter 1. What does it mean if points are collinear? They exist on what? The same line. Yeah, they exist on the same line. So are these points collinear? Well, they'll be collinear if they exist on the same line. Well, if they exist on the same line, wouldn't they have to have the same slope between them? So that's how we would figure this out. We're going to write check to make sure same slopes. So now we're going to have to check all their different combinations. So I'm going to start off with negative 6, 5 and 1, 7. So we're going to work y2 minus y1 over x2 minus x1. Give me more space here. I'll call the first parenthesis x1, y1, the second one x2, y2. And we know our slope is y2 minus y1 over x2 minus x1. Let's bring it up here, and now let's substitute in. So we're going to have our slope is equal to 7 minus 5 over 1, not minus 6, 1 minus negative 6. You got it. That double negative on the bottom makes a positive. So 7 minus 5 is 2. What's 1 plus 6? 7. Thanks, Chase. So now we're at 2 sevenths. Now I have to check all the different combinations. If all the different combinations are 2 sevenths for the slope, are they collinear? Yes. If even one combination is not 2 over 7, are they on the same line? No. So let's check another combination. So we did the first two. Should we do 1, 7 and 15, 10? All right, let's do that. So I'll say this is x1, y1, x2, y2. So our slope will be 10 minus 7 over 15 minus 1. 10 minus 7 is 3. 15 minus 1 is 14. Is that 2 over 7? No. So can I stop here? Yeah. Are the points collinear? No. Points are not collinear because they have different slopes. Can I move on to the next problem? All right, number 9 is saying, does the point 4, negative 1 lie on the line 3x minus 2y equals 10? Don't write this down, but I'm just going to go back to it. Remember when we were talking about the equation of a line in slope-intercept form, y equals mx plus b? We discussed, we said m is the slope, we said b is the y-intercept. What did we say x and y were? Anybody remember, Bridget? Exactly, any possible combination of points that exist on the line. That's what x and y represent. Now, I'm looking at this equation they're giving us in number 9. this is an equation of a line. This is a linear equation. The way I know it's a linear equation, there's a y, there's an x, and there's no exponents. There's no exponent on the y, there's no exponent on the x, just the two variables x and y. That's how I know it's a linear equation. So if I wanted to manipulate this, could I put this in the format of y equals mx plus b, the slope-intercept format? I can. It's not necessary for this problem, but we can because it is an equation of a line. Now, every point is an x comma y, right? Well, what I can do to see if this point exists on this line is I'm going to plug in 4 for x, I'm going to plug in -1 for y, and if the left side equals the right side, then it exists on the line. If the left side doesn't equal the right side, then it does not exist on the line. So I'll write it out for you. Substitute in if left side equals right side, point exists on the line. So I'm going to take 3x minus 2y equals 10. Should I give you a second to catch up? Okay, so now I'm going to substitute in. So I'm going to have 3 times 4. So I substituted in the 4 for x. And I'll substitute the -1 in for y. So we have minus 2 times -1. We want to know, does that equal 10? So let's go here. 3 times 4 is 12. What's -2 times -1? Positive 2. Does that equal 10? Does 14 equal 10? No. So does the point exist on the line? No. All right, let's do another problem. All right, find the equation of a line with a slope of 3 and an x-intercept of 5. Well, whenever I ask for an equation of a line, generally speaking, don't I want the format of y equals mx plus b? Isn't that the slope-intercept form of an equation of a line? Okay, now, in y equals mx plus b, for this to represent a line, I need values for m and I need values for b, right? If I have a number for m and I have a number for b, then this is a good equation of a line. So it says this line has a slope of 3. Where should I put that 3 in for? Which variable? James. M. So this is going to be y equals 3x plus b. Is this good enough? No. It says it has an x-intercept of 5. Is b the x-intercept or the y-intercept? The y-intercept. So can I just put in 5 for b? No. But the x-intercept is a point, right? Isn't this the point 5, 0? And don't x and y represent all the points that exist on the line? So what I can do is I can take 5 substituted in for x. I could take 0 substituted in for y. And then I can solve for b. I could solve for that variable. I'll write out what I just said. So I'm going to say substitute 5, 0 for x and y, then solve for b. So now we're going to have y equals 3x plus b. I'm going to put a 5 in for x. I'm going to put a 0 in for y. So I'm going to have 0 equals 3 times 5 plus b. Now let's go ahead and simplify. So I'm going to have 0 equals 15 plus b. Well, how would I now solve for b? Adam? Good. Subtract 15. So b will equal negative 15. Do I now have enough to correctly represent the equation of this line? Absolutely. So we'll go back here. We're going to have y is equal to 3x minus 15. All right, so now I'm going to step it up a little bit more, make it a little bit more difficult. Now I want to find the equation of a line that contains the point 7, negative 3, and 4, 1. My first question for you, is this either a horizontal or vertical line? I know it's not a horizontal and I know it's not a vertical line. Can someone tell me, just by looking at these 2 points, how do I know it's not a horizontal and it's also not a vertical line? Connor?
Because the x-coordinates and y-coordinates aren't the same.
Exactly, because the x-coordinates and the y-coordinates are not the same. So had the x-coordinates be the same, then it would be a special case. Or if the y-coordinates were the same, then it would be a special case. This is not a special case. This is just your normal line. So we need to figure out y equals mx plus b. We need to get a value for m and a value for b. So my first step, write it out, use the 2 points to find the slope. Don't we have a formula if we have 2 points how to find the slope? Yeah, so we're going to use m equals y2 minus y1 over x2 minus x1. So now I'm going to have 1 minus negative 3 over 4 minus 7. Did I lose anybody, or are we all good? All right, let's keep going. Our double negative here makes a positive, so 1 plus 3 is 4. 4 minus 7 is a negative 3. Did we just find the value for m? Yes. We now have m is equal to negative 4/3. Remember, I always assign the negative to the numerator, but it really doesn't matter. All right, so that's our first step. Then we're going to use the slope and one of the points to solve for b. So now I have y equals negative 4/3 x plus b. So now I have a choice. Do I want to use the point 7, negative 3 or the point 4, 1? It doesn't really matter. You tell me, which one do you want to use? Connor?
Point 4, 1.
Sure, we could use the 0.41. So what I'm going to do, if we're using the 0.41, that 4 is going to go in for x, and the 1's going to go in for y. The 4 is going to go in for x, the 1's going to go in for y. So now I'm going to have 1 is equal to negative 4 over 3 times 4 plus b. All right, it's not going to be a pretty number. So I have negative 4 over 3 times 4. Can I just multiply these? So negative 4 times 4 is negative 16, and then 3 times 1 is just 3. So now let's bring it up here. I'm going to have 1 is equal to negative 16 over 3 plus b. Just so I have more room, I'll write it down here and then I'll erase. 1 equals negative 16 over 3 plus b. You can add that 16 over 3 over to the other side and then make a common denominator and add, or you can right now eliminate the denominator. How would I right now eliminate the denominator? What would I do? How would I eliminate the denominator here? So solve for b by eliminating the denominator. Good. We're going to multiply both sides by 3. That's how you eliminate the denominator in an equation. So everything gets multiplied by 3. So now I'm going to get 3 times 1 is 3. These 3's cancel. So then I'm left with negative 16. And then 3 times b is just a 3b. Do we know how to solve this now? Absolutely. We're going to add 16 on both sides. So we're going to get 19 is equal to 3b, then divide by 3. So b is equal to 19 over 3. Do we now have a value for m? Yes. Do we have a value for b? Yes. So now we can go back and plug into our equation y equals negative 4/3 x plus 19 over 3. That's the equation of this line. All right, finish copying this down because I'm going to have to erase so we can do the next problem. Can I erase? Are you still copying? Okay. Okay. All right, next one. We want to come up with an equation of a line that is parallel to 4y minus 10, 4 times the quantity of y minus 10x equals negative 24 and has a y-intercept of 1. All right, first thing, we know we want an equation of a line, so once again, we want y equals mx plus b. I need a value for m and I need a value for b. What do I already have? We're coming up with an equation of a line that's parallel to 4 times the quantity of y minus 10x equals negative 24 and has a y-intercept of 1. What do we already have right off the bat? So we have the y-intercept. What's that y-intercept? 1. All right, and then it's saying our new line is parallel to this line. Well, what do we know? Lines that are parallel have the same what? Jocelyn? Slope. Right now, can I identify the slope with how it's written? No. What do I need to do to this equation to make sure that I have the correct slope? Put it in what format? y equals mx plus b. So I'm going to take this and I'm going to put it into y equals mx plus b. So there's a couple of different ways we could go about this. All depends on your algebra skills. How many people would start off this by distributing in a 4? How many people would divide 4? All right, dividing 4 would be the fastest way. But if you distributed in the 4, you'd get the same answer either way. I'm going to go ahead, since negative 24 goes into 4, that is the fastest way to do this. So I'm going to divide by 4. So now we have y minus 10x equals negative 24 divided by 4, which is a negative 6. What should I do now to get this into y equals mx plus b format? Chase. Add the 10x. And how should I write it on the right side, Chase?
Y equals 10x minus 6.
You got it. All right, so this is the equation of this one. What is the slope here? James. 10. Our slope is 10. So now in our new line, we know we're using y equals mx plus b, and our slope is 10. So y equals 10x. And what did we say the y-intercept was from the beginning of the problem? 1. So isn't this y equals 10x plus 1? Could you have done this problem if you didn't remember that parallel lines had the same slope? No, you had to remember that. All right, let's step it up a bit. Can I move on to letter D? Okay. So here they're saying, come up with an equation of a line that has an x-intercept of 8 and passes through the point 8, 5, root 2. Well, let's go to this. If it has an x-intercept of 8, that's different than a y-intercept. Do we agree? How do we represent an x-intercept of 8 as a point? Really? 3 people? That's it? Jocelyn? 8, 0. And then the other point is 8, 5, root 2. What do I really, really hope at this moment you recognize? Only one person? Mariana? Good. The x's have the same coordinate. X's have the same coordinate. What does that mean? Since the x has the same coordinate, is it moving left or right at all? No, it's only moving up and down. If it's only moving up and down, what kind of line is it?
Vertical line.
It's a vertical line. What's the equation of a vertical line? X equals or y equals? X equals. And x is going to equal the x coordinate. What's the x coordinate? 8. All right, let's say you couldn't do this. All right, you could have drawn a sketch here. So we're at, let's say this is 8, 0, and here's 5, root 2. Isn't that what that line would look like if you did a quick sketch? So you can always try to sketch if I give you 2 points to get an idea of how it looks. Okay, so now letter E is saying we are perpendicular to the y-axis. Right, we need a visual here. Definitely need a visual here. Which one's the y-axis, the vertical line or the horizontal line? Chase? The vertical line is the y-axis, the horizontal line is the x-axis. So now it's saying we're going to be perpendicular to the y-axis and pass the point 11, root 3. You don't have to know what root 3 is. You don't. All you have to do is say, okay, well, I'm going 11 to the right, and then I'm just going to pick some random spot and say that's root 3. So 11, root 3 is this point right here. Now, if we're going to be perpendicular to the y-axis, don't perpendicular lines make right angles? So if I have to be perpendicular to this y-axis, what kind of line do I have to draw? Kinds of line, not Olivia, not James or Chase or Adam or Mariana, Milo. Good. Wouldn't, to be perpendicular to this y-axis, wouldn't I have to draw a horizontal line? And now I have to draw a horizontal line that goes through this point. Right there. This is the point 11, comma, root 3. So what's the equation of a horizontal line? Y equals or x equals? Y equals or x equals for a horizontal line? James? Y equals. Y is going to equal the y coordinate. What's the y coordinate? Olivia? Root 3. You got it. All right, letter F. Again, we need to come up with an equation of a line between these 2 points. Not Olivia, not Adam, not Chase, or James, or Mariana, or Milo, or Jocelyn, or Bridget. Somebody else. Tell me, what do I hope you recognize here? Not Connor either. He's recognized this before. Somebody else. I'm looking at I'm looking at Maya or Natalie or Sophia. Colin, saving the day. Not the y-intercept, the y coordinates are the same. The y coordinates are the same. Since the y coordinates are the same, would it help if we did a visual? You can. So it's saying go over 2, so here's 2, up 5, there's 5, so there's the first point. Then it says go all the way to 24 and go up 5. What kind of line is this? Horizontal line, and that makes sense, right? Because the y is staying the same. The y is staying the same. It's only moving left or right. It's not moving up or down. So it's only moving left or right. That's a horizontal line. For a horizontal line, are we y equals or x equals? Horizontal line, y equals or x equals? Colin. Y equals the y coordinate. What's the y coordinate, James? 5. You got it. Okay, so this is nothing new. So where it says practice, I'm going to have you try some of these on your own, but I'm going to do one of them with you, which I haven't showed you yet. Let's look at number 2A, where it says, are these lines parallel, perpendicular, or neither? So remember, parallel equals same slope. Perpendicular equals opposite reciprocal slopes. Remember that? All right. But before we can decide if they're parallel, perpendicular, or neither, what do I have to put all the lines in? What format? Adam. The slope-intercept format. Exactly. Y equals mx plus b. So I'm going to take 6x plus 2y equals 10. Natalie, how do I put this in y equals mx plus b format, the slope-intercept form?
Get the y to one side and the rest to the other.
Excellent. We're going to get the y to one side and everything else to the other side. Maya, can you tell me what our first step to get y by itself will be? You got it. So we're going to have 2y equals negative 6x plus 10. Emily, what should I do now?
You're going to divide by 2.
Good. We're going to divide everything by 2. So we're going to have y is equal to negative 3x plus 10. So that's the first one. So now we're going to have 3y equals x. Do we agree there's really a 1 here in front of that x? Oh, that's a 5. Sorry. Is that what you're going to tell me, Adam? Thanks. Okay, so now we have 3y equals x. Do we agree there's a 1 in front of that x? All right, how do I get y by itself? What do I have to do? Soph? divide by 3 on both sides. So y is equal to 1/3 x. So now we're going to look at their two slopes. I have a -3 and I have a positive 1/3. Do we agree this first slope, is -3/1? And the second slope is 1/3. What's their relationship? So they are perpendicular because they're opposite reciprocals. So part A, the lines are perpendicular. All right, I want you all to do part B now. Okay, so if you manipulated these equations to put them in slope-intercept form, you should have gotten y equals 2x minus 1 and y equals -2x plus 2. How many people adjusted the equations properly? Excellent. All right, so we got a 2 and a -2. Parallel, perpendicular, or neither? Neither, you got it. Neither, neither, potato, potato, all the same. All right, what do I want you to do next? Try letter C. Try letter C. Are we ready? Who wants another minute? All right, let's do this. So now we're containing the point negative 8, 3 and perpendicular to the line 3y plus 12 equals 4x. The first thing you want to ask yourself, okay, well, if lines are perpendicular, their slopes are what? Not just reciprocals, opposite reciprocal slopes. So I'm going to take the 3y plus 12 equals 4x, and I need to figure out the slope. How am I going to figure out the slope? By putting it into slope-intercept form. Not slope formula, slope-intercept form. Y equals mx plus b, right? So I'm going to subtract the 12, so 3y equals 4x minus 12. Then I'll divide by 3 under everything. So y is equal to 4/3 x minus 4. So the slope of this line is 4/3. Hi. Yeah, I have a stapler. The slope of this line is 4/3. So what is the slope of the perpendicular line? Bridget? Negative 3/4. So now we know the new line. Let's get some more pages here.
Miss Applebar?
Yeah.
I actually hid Mr. Lamson's stapler so I could come in here.
Of course you did.
I should unhide it, right?
Yes, you should.
Let him find it. What do you think? Second option?
It's not his classroom. That's messed up. So we have y equals negative 3/4 x plus b, right? Isn't that our new line? Is this good enough to say that's the equation of the new line? No, I still need to find the value for b. Well, they did say it contains the point negative 8, 3. So how am I going to use that point to help me find b? Mariana? Plug it in for x and y. You got it. So now I'm going to have y is equal to negative 3/4 x plus b. I'm going to plug in 3 for y and negative 8 for x, and then I'm going to simplify. Multiply across. What's negative 3 times negative 8? Positive 24. 4 times 1 is 4. What's 24 divided by 4? 6. What should I do now to solve for b? Subtract the 6. So we're going to get b is equal to negative 3. So what's the equation of our new line? Y equals negative 3/4 x minus 3. Yeah, you did. Chased it in. Okay. Let's have you graph. I think if you graph just one, that's good enough, right? Here, graph this one. Graph the second one. Negative 10x plus 2y equals 8. Before you can graph, what format do you want to put it in? Slope-intercept form. You got it. All right, how many people got y equals 5x plus 4 as their slope-intercept form? Perfect. So now when you go to graph this, your slope is 5/1. Your y-intercept is 4. So you start on the y-axis, go up 4, And then from there, you're supposed to go up 5 to the right 1. But is there room to go up 5 to the right 1? No, so we got to go the other way. Instead of going up 5 to the right 1, we're going to go down 5 to the left 1. You got it. And then you connect with a line, and there's your line. How many people got this correct? Good. Do you want practice with one more, or do we want to call it a day? Call it a day. All right, we are done.